Hello again. This is Mr. Harney talking about another lecture in the lives of the noble humans. This lecture will be on none other than the philosopher Rene Descartes, whom I have written several papers on during my master's degree and to whom I own an indelible gratitude. Life of Descartes, who wrote Discourse on Method in 1637 and Principles of Philosophy in 1644. Descartes was indeed my first introduction to philosophy, and he marked the beginning of modern philosophy, ending only with Hegel, who marks the contemporary period in continental philosophy. René Descartes was born in 1596 in the Brittany area of France. From 1604 to 1612, he was college educated, and after travel in Holland, Germany, and Italy, in 1628 he settled to a quiet life in Holland. It was there where he proceeded to write major works in mathematics, philosophy, and science. He firmly continued on to a voluminous correspondence with the major scholars of his day for 22 years, until his Descartes' body caught fever and died in the February of 1650. Following upon disturbing dreams in late 1619, Descartes was 24 years old, and his life work became the creation of a systematic philosophy which encompasses all branches of knowledge. The system was based on a few undeniable principles and all knowledge from them, so that metaphysics, physics, mathematics, morality, and politics would all cohere. As I reflected upon my own journey, I also went to college for 8 years. And following upon disturbing events in late of 2022, 4 centuries after that of Descartes, I had been 25 years of age, and I had proceeded to write some of my life's work, not in writing mathematics, philosophy, and science, but in writing history, philosophy, and science. I followed in the metaphor of Descartes. Quote, "Philosophy as a whole is like a tree whose roots are metaphysics, whose trunk is physics, and whose branches which issue from this trunk are all the other sciences." End quote. My point is that the notion of a single, all-embracing method is contrary to that of Aristotle, for whom all the different fields of human knowledge have their own subject matter and appropriate method. I here compare Descartes to his contemporary in England, Francis Bacon, whom we have discussed, who also thought that a new beginning in human knowledge had to be brought about. But what was Descartes' plan to achieve this? Aristotelianism rejected in toto, completely, entirely. What would survive from Aristotle's school would be an abiding enthusiasm for Euclidean geometry. Descartes' program was systematic, deductive, and methodological in the sense that from a few self-evident principles, knowledge of complicated theorems could be generated, provided only that the correct method was followed. It is fair to note that Descartes was mesmerized by mathematics as much as my hunch for a new history, to see in the structure, method, and certainty of mathematics the model for all human knowledge. Indeed, as we have learned, Galileo and Newton, more to say on Newton's excerpt later, were also convinced that physics should follow the geometrical method of analysis and synthesis. Descartes' project was assisted by his division of the world into mental and physical substances, thinking and corporeal substances. Physics, for example, works well with corporeal substances, but the very nature and essence of corporeal substance, or matter, was extension in length, breadth, and depth, to quote Descartes there. Thus, geometry was able to represent faithfully the very essence of the subject matter of physics. Physics could be geometrical. And as Galileo before, and Robert Boyle and John Locke after, Descartes made a distinction between the primary and secondary qualities of matter, all of course being the product of interaction between corporeal things and feeling subjects. Physics was the science of determined, extended things in motion. In other words, the objects or bodies of experience, stones, chairs, airplanes, etc. Of course, in terms of airplanes, Descartes had no such experience. But Descartes did have stones, and he did have chairs. and these are in essence extended and capable of geometrical representation. But what of the possibility of unseen and unseeable corpuscles of what makes up the universe and all that is in it? And we'll get into this corpuscularian philosophy. Clearly from his writings, Descartes wanted certainty in his architectonic system of knowledge. What happens to the tree if the roots contain such a major unsupported hypothesis? Robert Boyle, the figure that we will mention later, an atomist, will later face the same question, and depending upon the answers, different positions in theory of knowledge are essentially derived. For example, instrumentalism, whereby theories are believed not to tell us about unseen deep structures, but about how to manipulate surface events. For example, fallibilism, whereby theories are believed to be about deep structures, but we only provisionally believe them until a better theory is developed. For example, absolutism, whereby we believe that our theories are true and will remain so. Hypotheses and experiments in science were matters of which Descartes eventually had to give an account. Early works of his lifelong project include Rules for the Direction of Mind, written in 1628, Discourse on Method in 1637, his Meditations on First Philosophy in 1641. These works were programmatic and very general in scope. But another writing was extremely substantive and very specific. And this was his geometry, his optics, and his meteorology. These better-known works were statements of an idea, the expression of a hope and vision of a deductive, coherent, certain body of all-encompassing knowledge. But this, for Descartes, was not enough. In Descartes' last work, his major last work, The Principles of Philosophy, written in 1644, the promises had to be kept, the program accomplished, with subjects concerning free will, prejudice, laws of motion, laws of impact, planetary orbits, comets, rainbows, the moon, mountain formation, tides, minerals, combustion, glass-making, gravitation, magnets, etc. At the same time, Descartes was a real philosopher and a real scientist. So extensive was his list of topics that he had wrote concerning about what he claims, quote, that there is no phenomenon in nature which has not been written about in this treatise, end quote. For the time of the 16th to 17th century, this was, for the most part, entirely true. And no one, not even Descartes, could actually explain mineral formation or ocean formation totally a priori. Educated guesses, hypotheses, and experimentations had to enter into Descartes' program eventually. But how were these accommodated, given his concern for certainty, and his greatest goal, that of a systematic science? If one has read ancient and medieval philosophers, one will most certainly know that in the history of philosophy, Descartes' problem was recognized by both Aristotle and St. Thomas Aquinas, one after Plato, the other after Augustine. Obviously, to argue from an effect to a cause was always a problem, unless one could first completely enumerate all the possible causes, and second, eliminate all but the chosen. In practice, the second task is difficult, but the first is conceptually impossible. Aristotle called this problem the, quote, fallacy of affirming the consequent, end quote. And so, for information on Descartes, you should look up J.R. Vrooman's work called René Descartes, a biography, written in 1970 and published in New York. In my research, I have historically found that Descartes knew of Galileo, but he did not mention him in his major works. Both individuals wanted to mathematize physics. Both individuals strove to examine physical matters with mathematical reasons. Both individuals sought and thought that there is no other way of finding the truth, veritas in Latin, than through mathematical reasons. See, Roger Aru Descartes as critic of Galileo's scientific methodology. And that was written in 1986, and also William R. Shea in 1978. Although Descartes critiqued Galileo, he still had assumed that acceleration uniformly increases with the distance traversed rather than the time elapsed. One of the most lasting and monumental scientific achievements of Descartes was the creation of analytic geometry. At this time, science had not yet been truly mathematized. At this time, there had only been the Archimedean-like rendering of scientific problems into Euclidean geometric form. This was the method used by both Galileo and Newton. Distance, for example, is represented by a line. Time is represented by a line as well, and solutions to the unknowns are derived by geometrical constructions. But in his geometry, Descartes represented different line lengths by different variables and converted geometry into algebraic steps, where laborious proofs laid out by Euclidean constructions were now reduced in order to be more clear, concise, and relatively simple. End of lecture.